Okay, so the graphs here, this topic is really just about becoming familiar with a set of different graphs. And there's four key graphs here: a hyperbola, a truncus, the square root function, and a circle. So we have to know those basics, four basic shapes, what they look like. And then as a group, we're going to then perform simple transformations, moving the graph left, right, up, and down on any of those graphs. And once you understand the transformations for one of the graphs, well, then we should be right with the transformations for all of the graphs. So let's have a look. All right, so the first of our graphs is our rectangular hyperbola. And so to get a feel, well, let's have a look at our graph here. So some of the key features of our graph here, let's plot points. Let's plot points. So if we plot some points, let's make it a bit bigger. So I guess the first thing to realise that 1 on x is the same as x to the power of minus 1. So there's our x to the minus 1. So let's start with 1 over 1. 1 over 1 is just 1. 1 over 2 is a half. 1 over 3 is a third. 1 over 4 is a quarter. So as you see, as x gets bigger, our y value will get smaller. What happens to 1 over negative 1? Well, that's just negative 1. 1 over negative 2 is minus a half. 1 over negative 3, minus a third, minus a quarter, etc. The key one here is think of a number between 1 and 0. 1 over a half is actually 2. 1 over a third would be 3, etc. 1 over 4 would be 4. 1 over 1/10, I should say. So 1 over a half, 1 over a third, 1 over a quarter. 1 over 1/10 would be 10, etc. 1 over negative half is negative 2. So I guess if we plot this section of the graph, let's just do a quick sketch. Okay, and our points, well, we start at the point negative 1, negative 1, negative 2, a half, negative 3, a third, negative 4, a quarter, and we get closer and closer to that axis, don't we? If I was to pick minus a half, I'd be down here at 2, minus a third, down here at 3, minus a quarter, down here at 4, and this side of the graph would go like that. If we consider the other half of our graph, again, the point 1, 1, if I go to x equal to 2, I get a half, x equal to 3, I get a third, x equal to 4, I get a quarter. So again, the graph gets smaller and smaller and it approaches the axis. If x is a half, I get 2. If x is a third, I get 3. If x is a quarter, I get 4. And my graph goes up closer and closer. Okay, so that's my general shape. Couple of important things here. This axis here, where that black line approaches and where that blue line approaches, they are called vertical asymptotes. Obviously, it's a vertical line, and an asymptote is any line that a function approaches. Never ever crosses it, but approaches it. The equation of that line is y equals 0. We have the same one here, my horizontal asymptote. The blue line approaches, the black line approaches, never ever crosses it, so there's no x-intercepts. Horizontal asymptote. Again, it approaches it, but is never equal to it. Oh, geez, I've buggered that up. The equation of that one, of course, is y equals 0. Sorry, boys. That one, of course, is where the x value is 0. It's easy to do. So think about that there, that x value there, 1 on 0. 1 on 0 does not exist. Therefore, that's my asymptote. So wherever my denominator is 0, that's when I'll have an asymptote. All right. So more formally, as x approaches in infinity in either direction, the value of y approaches 0. In other words, as x approaches positive infinity, y approaches 0. Similarly, as x approaches infinity, but negative, y also approaches 0. But because it's approaching 0 from the negative side, we sometimes put that little negative 0 there. Same thing over here, it approaches it from the positive side. So that's really just saying y gets really close to 0, but they're small positive numbers that are, as they get closer to 0. This one here is saying as it approaches 0 from the negative direction, but they're small negative numbers as they approach. So the final little statement there says as x approaches 0 from either direction, so it can approach 0 from either direction, the magnitude of y, so sometimes we use that symbol there for the magnitude, it approaches infinity. In other words, it gets really, really big. Okay, so typically though, we sort of just write as x approaches 0, y approaches infinity. All right. So this is where we're talking about the line y equal to 0 and the line x equal to 0. The graph doesn't cross either of those axes, so those lines are asymptotes. Hence the graph of 1 on x has two asymptotes, one at y equal to 0 and one at x equal to 0. Let's have a look at a graph sketch. So if I want to sketch the graph of 1 on x, 2 on x, and a half x on the same axis. So let's try and get some colours appropriate. Let's go with 1 on x to start with. What sort of a scale do we need? All right, we'll just make that 1, 1. Okay, so I know 1 on x goes through there, and if x is about a half, it goes up to 2. And if x is at 2, it's down at about a half. So maybe that part of the graph goes through there. And they approach the asymptotes. Probably is a good habit. We should put get in the habit of putting our asymptotes in straight away. Put the asymptotes in, x equal to 0, y equals 0. Okay, let's go back to 1 on x again. The point -1, it goes through there. If x is equal to, say, -2, well, 1 on -2 is -1/2. And if I put that -1/2 there, we get 2 if we put 1 over -1/2. And we go something like that. So it's going to approach those axes. So there's my 1 on x graph. Let's have a look at 2 on x. 2 on x just means it's 2 times bigger. So even if I plot points, if x is equal to 1 here, y is equal to 2 on 1, which is 2. So it would start there. If x is equal to a half, if x is equal to a half, 2 on a half is 4. So my graph doesn't quite let me sketch that high, but it's up there somewhere. And if x is equal to 2, well, y would be equal to 1. So you can see that hopefully you might not get the full advantage of it, but my graph is just twice as big. And the same is going to happen from this side. If x is equal to -1, 2 on -1 is -2. -2 on -2 is -1, so it might be there. And down here, it might be out here at 4. So my graph, I'm not going to get the right sort of curve there, might look like that. Yeah, there's my 2 on x. 1 on 2x, well, that's the same as a half times x, so it's half as big. So everything is smaller. So if I put x equal to 1 there, I get 1 on 2. So at x equal to 1, y is equal to a half. And if x is equal to 2, y is equal to a quarter. And if x is equal to -1/2, well, 2 times -1/2 is 1. Y is equal to 1. And at a quarter, it would be equal to 2. So you can see the graph, exactly the same shape. I'm trying to draw it with the same shape. but it's just closer to the axis. So the same thing's going to happen on this side. At a half, negative a half, it's going to be -1. At -1, it's going to be negative a half. -2, it's going to be negative a quarter. And at negative a quarter, it's going to be up here at -2. So ignore that other dot, and it looks something like that. So the key is, it's always going to have the same shape. So we'll talk about these as dilations, dilated from the x-axis. Okay, so if we dilate from the x-axis, it means that every y value gets multiplied by the factor. So here I have 2 times 1 on x. So each y value multiplied by 2, so every point has been stretched up. Here we're multiplying by a half, so every point is half closer. Okay, so we see there more formally then the dilation from the x-axis, which takes the graph of 1 on x to y equals 2 on x, is dilated by a factor of 2, so it's twice as big. Let's have a look at some of our other standard graphs. Okay. Well, we've only got one graph. We'll try and draw it on the one axis. So let's do the first one. We'll do that in. Let's do it in red. In fact, I'll put say in red. First things first, my horizontal asymptote hasn't moved. And that's at y equals 0. Now look at my other asymptote. The vertical asymptote occurs when the denominator is 0. Need the denominator equal to 0. Therefore, x minus 1 is equal to 0. X is equal to 1. So there's my... Now the other way to think about that, we've just finished doing some parabolas. If that's x squared, well, that one there, that might be x minus 1 squared, isn't it? So that minus 1 shifted it to the right 1 unit. That's exactly what that minus 1 there did, shifted it to the right 1 unit. So now, the 2 at the front just makes everything a bit bigger. Now for us, all we're really interested in is getting the basic shape. So we might plot a point. So if that's 1, that's the point at x equal to 2. So if I substitute 2 in there, I get 2 over 2 minus 1, which is 2. So I might make that 2 and that 4 just to make it scaling a bit better. So my graph, that's one part of it. Now, because they're asymptotes, we know we have no intercepts. But for the other part, well, I know I'm going to cross over. I've got to be below the line here. And I'm going to cross somewhere there. So I need a y-intercept. So the y-intercept, x is equal to 0. I get y is equal to 2 over 0 minus 1, which equals -2. So my y-intercept is at 0, -2, which we're saying is there. So we'll draw the graph like that. Okay, so key features, the asymptotes, put them in first every time, find an intercept, and then sketch in the proper quadrants, top right, bottom left. Y equals 2 on x plus 3. So again, the vertical asymptote, I need the denominator equal to 0, which means x is equal to 0. So, in fact, instead of doing it there, let's do it down here. See my vertical asymptote still at x equal to 0. Now, plus 3, what does that do? What impact does it have? Well, if I go back over here to my parabola, that's x squared. What's that one? That one might be x squared plus 2. So it shifts everything up 2 units. So that 3 there shifts everything up 3 units, which means my horizontal asymptote now goes through there at y equal to 3. So everything's shifted up, which means we know that the graph is up here in the top right corner, and it's also somewhere down here in the bottom left corner. All we need to do now is actually find that point there. So there is an x-intercept, which means y is 0. So the x-intercept, if I put y equal to 0, I get 0 is equal to 2 over x plus 3. Subtract 3. Minus 3 equals 2 over x. Multiply the x across. Now divide by 3, or negative 3. I get minus 2/3, which seems quite feasible. So the plus 3, that plus 3 there, shifted the graph up 3 units. Nothing there with the x value, so the asymptote stays the same, and then we just find our x and y intercepts. Let's do 2 more graphs here while we can. Again, first things first, plus 1. So my vertical asymptotes, it's left 1 unit, isn't it? So it's at y equals negative 1. That negative 3 there shifts everything down 3 units. So the horizontal one is at, I'm buggering this up, is at y equals negative 3, and the vertical is at x equal negative 1. Sorry, boys. So the graph has been moved to the left 1 unit. X equals negative 1. It's been shifted 3 down. So I'm going to just make this my scale at y equals negative 3. So now my graph, even if I find x, y intercepts, it could be 2 here. It's hard to tell, isn't it? So if I go over, actually let's work in here. I'll work over here. So if I put x equal to 0, y is equal to 2 over 0 plus 1 minus 3, which is 2 minus 3, which equals negative 1. So 0, negative 1 is, we'll say there, which means straight away I've got an intercept, an x-intercept there somewhere. So if I put y equal to 0, I get 0 equals 2 over x plus 1 minus 3. Bring the 3 across. 2 over x plus 1. Multiply it up. Bring the 3 back down. And subtract 1. Minus a third, which seems quite feasible. Minus a third there. So we've got a graph here that goes through like that. Try and do one continuous line, and the other section is down in through here. Okay, so the key ones, Mr. Rice is really keen on it. The lines need to approach our vertical and horizontal asymptotes. They don't curl away. Final one, we've got room. I think I've got room over here. What's happening? Plus 1. We already decided that shifts everything to the left 1 unit. So the asymptote at x equal to negative 1 again. Let's put that there. So there's no shifting up and down, so I'm better off changing that, aren't I? So let's put our asymptote again in red. Horizontal asymptote in red. That hasn't moved, so that's still at y equal to 0. Now, this negative sign here is a bit of a key. That reflects everything. What's the difference between x squared and minus x squared? Well, x squared is that way. Negative x squared is that way. It's upside down, isn't it? So instead of drawing it up here, so if I do a quick sketch, we would draw it like that. Instead of doing it that way, I flip everything upside down. So instead of up like that, instead of up that way, I'm going to sketch it that way. And instead of here like that, I'm going to sketch it up here like that. So my negative hyperbola is in the other two quadrants, okay? It's in the top left and bottom right. Let's check that. We shifted our graph. We're looking for an intercept. So a y-intercept. So the y-intercept, if I put x equal to 0, negative 2 over 1 is equal to negative 2. So I get the point 0, negative 2, which seems okay. All right. Jot those down. Don't forget, have a little bit of play with Desmos if you need to. Just sketch a few. Just type them in on the calculator, see what happens if you add 1, minus 1, etc. And then really, what I'd like you to have a go at is these first two questions. Have a bit of a go at those tonight before you come to school tomorrow.